Welcome to the first video in the 3D Printing and Fabrication Concept series of tutorials and guides. I'm your host, Aaron Ellis. In this session, we will discuss 3D printers, how they work, what they can do, and how we might put them to use. We will also explore the marketplace for inexpensive devices and learn where to find object files for 3D printing. With that introduction out of the way, let's get started. As cool as 3D printing is, it's not magic. It works by separating complex model designs into simple slices, reproducing those slices and stacking them one layer on top of another until they form a completed object. If I handed most people a ball of clay and asked them to sculpt the portrait of a celebrity, they probably couldn't do it. But if I instead asked someone to trace 100 or more patterns on cardboard, cut them all out, and glue them together, then anyone, even you or I, could make almost anything. That's the essence of 3D printing, separating complex designs into simple shapes and then stacking the slices. There are many different rapid prototyping technologies and processes in use today, but they all fall into one of two major categories: additive or subtractive. Subtractive manufacturing is any process where material is removed to create something. True 3D printers are additive devices that combine many layers of plastic, resin, metal, or many other materials to construct complex shapes. Some of the most common of these approaches in the 3D printing marketplace include FDM, SLA, LOM, SLS, and PolyJet. Fused deposition modeling, or FDM, draws many layers in thin lines of liquid or viscous material onto flat surfaces. Molten plastic is most often used, but other FDM materials for specialized printers can include concrete, carbon fiber, and even chocolate. This printing process is often inexpensive but slow, and the results produce durable but low-resolution models. FDM printing could be simulated at home with a hot glue gun, a steady hand, and a lot of patience. Stereolithography, or SLA printing, solidifies layers of patterns from tanks of photosensitive liquid resin using lasers or illuminated images. The SLA process is fairly inexpensive and slow, and the resulting prints are typically highly detailed but fragile. Due to the positioning of SLA illuminator arrays along with clear-bottomed trays, this approach creates objects in an upside-down fashion as they emerge from liquid resin tanks. Laminated object manufacturing, or LOM, cuts hundreds or thousands of patterns from sheets of standard paper, colorizes the edges, and glues them together to create full-color physical objects. LOM is unique in that it uses both subtractive and additive manufacturing processes to create physical models. The LOM process is quick, inexpensive, and produces colorful and detailed objects. LOM printing can be simulated at home using readily available paper, cardboard, scissors, craft knives, and glue. Selective laser sintering, or SLS printing, melts layers of powdered material, usually metal or polymers, into solid shapes using high-powered laser beams. The SLS process is expensive and slow, while the resulting prints are detailed and durable, depending on the materials used. PolyJet printing sprays successive patterns of photosensitive resin onto build platforms using a technology very similar to common inkjet desktop printing. The PolyJet process is expensive, but also very fast, and the resulting prints can be highly detailed and durable, depending on material choices. PolyJet printers can mix and match materials with different colors, elasticity, and hardness values. There are hundreds of 3D printing devices on the market today, and it would be impossible to list all of them in this video. However, we can look at a few examples from among the various printing technology categories. One of the most important requirements for 3D printing is some object to print. Most device manufacturers include a handful of example print files to test or calibrate their machines, but typical users will want to print objects of their own that are personally or professionally meaningful. If you are a seasoned modeler or sculptor, you probably already have a collection of your own 3D art that you would like to print. However, not everyone is a hands-on spatial artist. Fortunately, many hundreds of thousands of 3D object files can be found online for free or for purchase on various websites. Some are better than others for use in 3D printing. A few of these sources will be discussed here. There are many freely available sources of 3D models on the Internet. Thingiverse, GrabCAD, and Sketchfab are just a few such outlets. However, many free objects are designed for viewing or animating rather than printing. It is important to check any downloaded object file for suitability of 3D printing. Additional work may still be required to repair these objects for printing. There are also many commercial vendors for 3D models, along with contracted modeling and sculpting service professionals. TurboSquid, CG Trader, and Sketchfab, again, are among such sources. As before, ensure that the models you wish to obtain for printing were designed for that purpose, or they may need some tweaking after the sale. My favorite way to source 3D object files for printing is to just make them myself. Modeling, sculpting, and scanning my own objects requires a lot more work than downloading ready-made files from the Internet, but it is also a lot more rewarding. That's it for this episode in the 3D Printing and Fabrication series. Have fun exploring the marketplace for 3D fabrication devices, material options, and printable object files.